Okay, so recordings are starting. There's also the attendance register on the chat. If you can just follow the link and just select the attendance. And then let's start on study unit 5. So study unit 5, we'll start looking at your discrete probabilities. So included in the discrete probabilities are random, then also binomial and Poisson. So that is the three discrete probabilities that we will cover in this study unit. So basically, looking at those three, and also, so in your assignments, but then in the exam, also important that you will get a question on each of them. So more important for the exam really is that you will get a question on normal discrete, on binomial, on Poisson. So at least 3 or 4 questions will be coming from this study unit. Okay, so when we look at discrete probabilities, and let me take this last one out because you guys are not doing that anymore. So the first part of the study unit focuses on random variables. Part of that random variables, you will need to work out what's the expected value, or basically the mean of it, and then also what is the variance of in that random variable. Then we will also look at binomial and Poisson, and there also you might be asked to work out the expected value or variance when it comes to those two as well. So the first part, if we can nearly look back at assignment 1, we talked about the random variable. In that, we also talked about discrete random variables and what is continuous. So this part that we are doing in chapter 5, we will look at discrete random variables. So again, if you can remember, discrete was anything like a 1, 2, 3, 4, 5, but it could also have been 1.5, 1.7, where your continuous was more numbers that are anything in between as well. So again, for now, this study unit on 5, we focus on discrete. When we get to study unit 6 and above, we will focus on continuous. So in a discrete random variable, basically it can ask you something, or you can get where it says let x be the number of TV sold in one day, and x can take on those variables of 0 TV sold, 1, 2, 3, or 4. And normally with a discrete, you will get that. Okay, so there's not with this one. So normally what you will then get, and let me, so if this was with 5 outcomes from 0 to 1, you will have that there's for each one of those, there will be a probability. So when it comes to discrete, they need to give it to you. So they need to tell you what these probabilities are. if you're working with binomial and Poisson, then you will be able to get it from the tables. But if we're working with um, the discrete, they need to tell us. So when you get a question like this table should be completed for you. It might be that, let's just put in a few numbers. So it might be that they leave, say, one of them out. And they ask you to work out things. But then there's a few things that we need to remember. So when you're working with a discrete, the total probability always needs to add to 1. So if I didn't give you the probability of x being equal to 4, you could have worked it out by adding the rest and subtracting it from 1. So that would have been 0.36, 0.7. Subtract it from 1 would have given you 0.3 as well. So this is basically when they tell you about discrete random variables, they would need to give you a table explaining the probabilities of each, and then they can ask you random questions around it. So they can ask you maybe what is the probability of x being bigger than 0 and smaller than 4 or something like that. But we will get to some exercises like that later on. But just to give a bit of context when we look at some of these examples. Okay. Okay, so you would remember again from assignment 1, study unit 1 and 2, when we looked at the number of and in the other instances distance, or if it was something like, if it wasn't age in numbers, but if it was, or time or something like that. So always the difference between what is discrete and continuous. But what will happen in the exam is they would tell you. So well, they would tell you this is a discrete random variable, or this is a continuous. So they're not gonna make you nearly guess what you're working with. So you don't need to worry about that in any case. I just wanted to show how nearly what we've done in study unit 1 and 2 nearly flows into the probabilities of study unit 5. Okay, then, and I've nearly talked about this already, but again, if we look at probabilities of discrete, the sum of the probabilities will be equal to 1, and any of the probabilities must be bigger than 0. So again, you can't have a negative probability in here, but you can have a 0. Um, so, but you can't have a minus 0.1 probability. So again, that can't happen. So you can't have a 0, a negative probability. You can have a 0 because then that will just not happen. So I think that is important, that you can have a 0, you can't just don't have a negative probability. Okay, so here you could have seen, so they could tell you the data in numbers so that you can work out a probability. from this probability, you could have done a bar chart if needed. I think I haven't seen a trace at all or something like this in the exam. And then two other things also that you need to be able to do is from that data nearly be able to work out expected value and variance. So let's just again, where was, so let's use this. I just want to see if I can. But again, I'm gonna to check if I have it in. So I'm gonna put it in Excel. So it was X. It was a probability. Let's just make sure that it is numbers. Okay, so that was for 4 numbers. And let's just make sure okay, so there is your values for this exercise. We're looking at the probability. So there's the probability for x equal to 0 is 0.4, then 0.3, then 0.2, 0.1, 0.1. Okay, so that again can't be. So let's just quickly check what I did copy, if it was right. Otherwise, I'm just going to change some of the, okay. So let's do 0.15. So that sum is at least equal to 1. Okay, and then...
Sorry, Gene.
Yes.
Will that always be equal to 1, no matter how many of those probabilities?
Yes, always. It needs to be equal to 1. So you can, when that is not equal to 1, then or there's something missing in there, else it is a mistake in the paper. So it always needs to add to 1. So there might be in the questions, you might have it something like this, where they haven't completed that, and they ask you now, what is that value? So then you will be able to say, okay, but everything else adds to 0.9. So what is left to get to 1 is the 0.1. So that is one of the rules of the discrete probability. But going forward as well, you will see from your binomial tables, when you work with a binomial table, it will add to 1. If you look at your Poisson tables, it will add to 1 when we go to, and let me see if I can draw it. So even when we go to your normal distributions, and we're going to start working with those distributions, everything underneath this graph will also add to 1. So so nearly you can from now on, nearly every probability that you're working with needs to add to 1. Okay, so, and I will nearly every time reiterate that when we get to some of these examples. Okay, so when you now need to work out an expected value for the variance, it's very similar to what we've done in, what was it, chapter 3. So we work out a mean. So how we work out the mean is nearly how we work out the expected value, is to say, so let's put it here, is to say x times the probability. It's 0 times the probability, but then we need to continue it for all of them, and then in the end you will add all of them together. So your expected value would be 1.1. So let's just go and look at that formula. So expected value is all the x's times the probability of that x, and you basically sum it for everyone. Okay, so when we go back to the Excel, it's the x times the probability, but you sum it across all of them to get you to 1.1 for this example. Okay, so that will be your expected value. Unfortunately, we can't with this just go and say work out what is the Excel mean, because this needs to be taken into consideration with the x. If we just say equal mean or equal average, you will not get the same. So for discrete probabilities, we're not being able to use the built-in functions in Excel. Okay, then to work out the variance, basically, again, if we look at the formula, so we've got the x, we need to minus the mean. So that is very similar to when we worked out other variances as well. You then multiply it with itself, but the thing that we need to add with or multiply with again is that probability. So basically it's saying it is that x minus the expected value, and let's just anchor that. To the power of 2 as we multiply it with itself, and then we still multiply it with the probability. And then in the end, we've done it for each one of them. So the variance in the end will again be a sum of all of them. And then if we needed to work out the standard deviation again, it will just be the square root of the variance. Okay, but when we get to an exercise using this, I'll show it on Excel again, because again, for both in your exams and in your assignments, you are allowed to use Excel. So it's not illegal. You are all allowed to use online calculators. So please use it. I will send this to you in any case as well um, on the chat. So I'll do that. Okay, so that was just quickly showing how to calculate the expected value and the variance when we're looking at the random variables. When you also, with binomial and Poisson, there will again be different methods to work it out. Let me just also make a note on that page that I want to share with you guys so that everything of this is nearly on one page. Okay, so I'm gonna skip this. So let's quickly check on the data that they used, if we got the same. So it's an expected value of 1.2, and then if you work it out, 1.66. So let's just change the data to what it was in that example. Okay, so expected value was 1.2. So again, you can just check this. I'll share the presentation as well. And then you can see the variance was 1.66, variance 1.66, and then the standard deviation of that 1.29. So again, depending if we round it off to 2, it will be 1.29. If we don't round it off and we make it bigger, then it will also be 1.2884. So depending on how we want to see it, we can change the number of decimals. Okay, so again, I rather that you work with things that makes it easier for you. So again, if it is easier to use Excel, please do. You can also use the calculator to calculate this. So it's not that you need to use Excel, but whichever one is the easiest for you to use, please do. Okay, so that was a quick summary of your discrete probabilities. Then just to look at binomial. So the binomial distribution, when I look at that, we look at the nearly 4 properties within binomial distribution. So the one thing I think it's probably number 2 is more important than number 1. But with binomial distribution, what we're basically looking at is the whole time we're looking at 2 options. So something happens or it does not happen. Or it's heads and tails that you have, or it is basically by saying something is a success or it's a failure. So the whole time, you basically looking in binomial distribution at 2 outcomes. So I think there's also sometimes a catch in some of the questions. So when we also look at some of those, and also be prepared when you do the assignment, they might the whole time talk about maybe the success, but they might ask you a question about the failure, just like they normally have a questions about is something incorrect or correct. So just be careful with binomial, what they're talking about. So if it is you're looking for the success in it, or are you looking for the failure? The other thing that is important with binomial, and it's not going to influence how you look at the questions, but they might ask it in a definition. So when you look at binomial distributions, it is supposed to be independent. So when I toss up a coin, it falls on heads, then what it binomial distribution supposedly saying is the next time I shoot up that coin again, it has the likelihood to be a head or a tail. The previous heads should not influence what the outcome is of your next trial that you are doing. Um, so that is supposedly how binomial distribution should be. And then also what the other thing that they can ask within a definition is basically that it is just a consistent number of trials that you are doing. So those two basically go very much hand in hand. Okay, so that is more definition around binomial distribution. Um, let's be honest, I love to ask a question in study unit 5 normally um, on some of the definitions and things like that. So binomial, probably one of those that is more likely to be part of a um, definition question as well. So especially for your assignment, really be prepared for that. Okay, we have the distribution formula for binomial, but again, nearly I'll show you with examples that we rather use the tables. So in your study guide, there is binomial tables. When you write the exam, um, part of the document that they will send to you before you write will tell you, okay, use tables or use the tables in your study guide, so that you don't need to nearly look or use the formula, because and I'll show it later to you. It's okay if you need to use this formula once, um, but if you need to use this formula for 3 or 4 calculations, it becomes a lot. And then it becomes very easy to make a mistake using it. And again, with all the assignments and exams that are timed, you can lose a lot of time on something like this. So again, I'll show you some easier ways to get to that. Okay, then the 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 way to calculate the expected value, variance, and standard deviation. So now it's a bit different. Um, so the expected value is, and this is normally always in the question that they will ask you as well. So we'll look at n, that is the sample. So they need to tell you what the sample is. and then you will what we call pi, but it is basically that rate of success or rate of failure. Um, so so that rate of success we will use in the expected value to calculate it. When we need to work out the variance, it's very similar, and then it's just 1 minus that success rate. Um, but I think very important to work out the discrete random variables. There was nearly you need to get a value for the expected value. When you use the expected value to work out what the variance is, yeah, you basically will work out what is the expected value for the binomial distribution by just looking at the information that they give you. Then the last one that we're going to look at is the Poisson distribution. What makes Poisson distribution different from binomial is that there is a time interval that is always added to the question. So again, there will be talk about a rate, which will be your lambda, so that we will get from tables, etc. as well. But the difference then comes in is they will add a time interval to it. So it can be per day, per minute, per hour, per month, anything like that, but there is a time limit to that. Okay. Then on your, let's just quickly see if I can get to that. On your Poisson distribution for your expected value, it's very simple. Let's just check where that is. Okay, I just want to check where. Okay, it's not in here, but did I not delete it or did I not? Okay, so what we needed to add here, so we will talk about the rate lambda. So again, we'll get to exercises where we have that, but that lambda will be equal to your mean, and that lambda will also be equal to your variance. So in the Poisson distribution, we don't need to work out anything. We will get it. So what they might ask again in a definition question with Poisson distribution is they might give you the rate that we're talking about, and it say it's 1.5 or 1.4, and then they can ask, but the rate is 1.4, median is equal to 1.4, variance is 1.4, is it true or false? So that can be nearly, and I think there is a question like that in here. So nearly the difference between discrete, binomial, and Poisson is that in discrete, we will need to get a table where we say, well, the probability of this number is equal to that. And we can nearly make a summary of that table. In binomial distribution, we're going to get things like sample size. We will get what the rate is, and then in Poisson, we probably also need to get what n is. We will need to get what lambda is, and then from there they can ask us a few questions. Also in the pack is the Poisson distribution function again, but yeah, again, if we need to calculate this 4 or 5 times to get to one answer, it is a lot. So again, if 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 you don't need to use it, I rather use again with formula sheets or the tables and things like that. Okay, so let's get to a question on this. And I don't know, we probably will not probably finish with all of the questions because I normally have a few, because it's very important study unit on to get nice marks. So again, if there's 3 or 4 questions on study unit 5 in your exam, that is nearly 4 questions that you want to get right. Okay, so in this, they ask us which of the following statements is a valid probability. And Peter, that now nearly comes back to what you asked at the beginning about equal to 1. So that's nearly how I would first look at it, is to say, let's look at which ones don't equal to 1 before we even look at all the weird other stuff that can happen. So let's see, does that add to 1? 0.512 plus 0.384 plus 0.096 plus 0.008. Okay, so the first one equals to 1. So that might be already the one that we are looking at. Okay, let's 0.1 plus that is 0.4 plus that is 0.8 plus that is 0.9, so it's definitely not 2. Okay, so that's 0.01, 02, 03, then plus that will be 1.01, so also not. Okay, that's 0.5, that's 0.99, so just short. 0.15 plus that is 0.4, plus that is 0.9, plus that is 1.2. Okay, so with this exercise, they only wanted us to check if when you add the probability of all the x's, that equals to 1. So that was basically what we needed to do in this exercise. If it will be that simple in your assignments, I don't think so, but it will probably more be a combination of these things. Okay, let me just quickly stop here and then get a check in. Okay, so let's go to the next one. Okay, so since it is again open book, I added the definitions and how to work some of the things out. So again, please use the tools that you have available. You don't need to remember all of these formulas and things like that. Okay, so before we work out the estimated value, we can rather first see with all the probabilities if we know how to get to those numbers. So if we look at probability of x bigger or equal to 2, so if we look probability x bigger or equal to 2, bigger or equal to 2, it is inverse free, then it should be 0.5 plus 0.15 plus 0.05, and that would be equal to 0.7. Okay, so we know that one is not correct because that is 0.2. Okay, so that should have been 0.7. Let's just get another color for x smaller or equal to 1. X smaller or equal to 1. Okay, so it's those two. Smaller or equal to 1, so it's 1 or 0. And that would be 0.3. Because if you add those two together, that would be 0.3. Okay, so let's look at what is if I look at x smaller or equal to 4, but bigger than 1. Okay, smaller or equal to 4, so it's everything smaller than 4, but bigger than 1, so it is from 2 to 4. So that is the correct one, but just look at the red and the purple is exactly the same area. So depending on how they've asked the question, you can see it's exactly the same answer and the same area that we're looking at. So quite interesting. Can ask it differently, but the reference is still the same area. Okay, and then the last one from the probabilities, x smaller than 4, so not including 4. X bigger than 2, not including 2, so it's only that one in the middle, so it should have been 0.15, and that's why that one was also wrong. Okay, then to work out the expected value, so I would have used Excel again. So by using Excel, that one. Okay, we will just remember that we took the x value, we multiplied it by the probability, and we will add all of those together. So if we needed to work out the expected value, it would have been 1,85. It was 18.5, so that was why that one was wrong as well, because it must be 1.85. Okay, so in here, what we looked at is the expected value that we calculated, but also we looked at different ways of working out what probabilities is from the table. And this is also definitely something that you will get in your assignment, is a set of questions that they will ask around the probabilities. and that you need to nearly pick which one is correct, which one is incorrect, which one doesn't fit. Um, Obviously, they could have added the variance question as well, but for now, looking at the three probability, four probabilities, and expected value. Okay, questions so far? Okay, cool. Is it helping? Is it making sense? I know the assignments are not open yet, so you probably also wouldn't have had exposure to this really. But yeah, hopefully as you work through the study guides with the examples, when it become making more sense. Okay, let's look at the next question. So here they just give us the data, and then they ask us to work out what is the expected value. Okay, so I again will rather use Excel. Again, it is there for us to use. And then to get to that expected, okay, so again, we worked it out as the x times the probability of it. We work it out for all of them, and then we sum all of them, and we get one of those answers, 0.78. Okay, so basically, if you didn't do it via calculator or via Excel, you would have just said 0 times that would have been equal to 0. 0 times that would have equal to 0.2. You need to do that for all of them and sum it in the end, which then would have given you the 0.78. Okay, so again, I rather use Excel because if I now needed also to work out the variance, one can just do it on that table. Okay, so in the next one, we're still working with discrete random variable. Within this, they give us a set of within that they give us a set of data, and then for this instance, they ask us a few probabilities, and we need to check which one is incorrect. Okay, so let's look at all of them again. Again, nice that one can use highlighters, which is now not available anymore because you're writing online, because it really helped one really to look at the things. So if we say probability bigger than 1, So probability bigger than 1, so it excludes 0 and 1, is 0.35. So those two added together would have been 0.35, but we're looking for the incorrect one. Okay, probability smaller or equal to 2, smaller or equal to 2. So 0.2, 0.6, 0.85. Okay, so that is also correct. Then probability of smaller or equal to 2. Okay, so it includes 2, smaller or equal to 1. It includes 1, so it is those two, so it's 0.6, which is correct. Smaller than 1, if I say smaller than 1, basically only looking at 0, which is 0.25, which is correct. So then obviously the last one must be wrong, but let's just see why. Smaller or equal to 1. Okay, so smaller or equal to 1, but bigger than 0. So it's only the number 1 that we're looking at, which is 0.4. Okay, so that is why that one is incorrect. Okay, but again, how I would look at it is nearly, I'll check for myself, okay, if I'm looking at that, that part that I've highlighted, so that is what I am looking at. And with this one, basically, we just need to go through the different options until we get to the wrong one. Okay. Okay, so that again, discrete random variable, they need to give you the information, so that you can then get to the answers. Okay, so in this one, so Peter, there you can see they don't give you everything. So firstly, you need to complete that, and then again, we're working with the expected value. Okay, so we can nearly use this sheet again. Okay, so we don't have anything for x0, don't have anything for x2, then for x1, for x2 it is 0.05, for x3 it's 0.2, for x4 it's 0.4, x5 it's 0.2, and then x6 we don't know that value, but we could have said, okay, that is equal to 1 minus the sum of the previous ones, okay, which will then be 0.15, which, interesting enough, was the answer of the first option, 0.15, but that is what we need to fill in there is 0.15 and not the expected length. So again, if we go and check what we worked out, it would have been the x times the probability. For each of them, we would have added together, and then your expected probability or your expected number would have been 4.2, which would have been option 5. Okay, so again, they don't need to give us all the probabilities because we know all of those probabilities need to add to one. So they can leave out one, then with you making the assumption that, okay, it all adds to one, so we can nearly fill that gap. They can't leave out two. So it couldn't have been that they leave out two unless they tell you that the two that's left out is the same probability or something like that. But you can't by yourself now suddenly know how the probability is split or anything like that. So yes, we can leave out one because the sum of it should be equal to one. So if I leave out any one of the probabilities, it's fine, but not more than one. Okay, the other thing that I think it's important is don't be sometimes, so you see 0, 1, 2, 3. So in this instance, it didn't start at 0, which is also fine. So they don't need to be for every discrete number a probability. So what this basically then means is there was nobody that had a minor operation that stayed for 0 days or for 1 day. So there was just not probabilities for those. So again, it could be that in the sequence, there is suddenly, it could have been 2, 3, 4, 5, 7. So just make sure that when you see some of these examples or do the assignments, it does not always need to be clean 0, 1, 2, 3, and 4, and that's your sequence. There can be numbers left out. It doesn't need to follow the exact sequence. There can be gaps in between the X numbers. Okay, that was up until here we only looked at this discrete probabilities. Um, Now we're going over to binomial, and what I've already added in the questions is the binomial table. And the reason why again is, so when we look at the questions and I look at something like this, for this instance, if I look at n equals 6, x is big or equal to 5, I need to work out what the probability is at 5, and then I need to add the probability at 6. So if I didn't use the formula page and I needed to go back to, where was that formula? This formula, I now would have needed to work out it twice. So I would have needed to say, okay, all my n's, I will need to replace it with a 6. All my x's, I will need to replace with a 5. I'll work out an answer. Then I need to redo it because now I'll replace all the n's with a 6, but all the x's with a 6 as well. Get that answer, and then I need to add the 2 to get my probability that it's a 5 or a 6. Where if I look at the table and I've identified what part of a table I need to work with, I can just look at two numbers and add that together instead of that whole thing that I needed to work out. So let's look at that 5 plus 6. So if I look at the table, n is 6, where pi is equal to 0.2. I looked at x, 5, and 6. It was the last two numbers. I just needed to add those two, which is then 0,0016, which that one is correct. But now imagine doing that calculation to get to 0,0015 and to 0,0001 to get to your answer. Again, a lot of work when you need to put into getting the formula right than understanding how to read it from the table, much simpler. Okay, so and I will send, I've done some practice exercises as well that I will send through to you. So that I again just showed how to look at the tables. So also we will probably only finish this next week, but every time where possible, I have included the tables so that it's just easier as reference for you guys as well. Again, there is online calculators as well. So if you Google a bit, you will be able to get. And so what I would normally do is just say binomial online calculator or something like that. And then sometimes all that you need to put in is the n and the pi, and it will give you a few options that you can look at. Okay, let's just look at the other ones as well so that I can pinpoint it for you. So we're still working with this table where n is 6. They need to give us the n. They need to give us the pi. Where they now ask us where x is exactly 2. So where x is 2, we look at 0,2458, which is correct. We're still looking for the incorrect one. Okay, where x, the same table, where x is 5, the probability is 0,0015. Okay, yeah, it's wrong. It should be 15 and not 05. So option 2 is definitely wrong. But let's look at the other ones as well. If they tell me x smaller or equal to 1, okay, so x smaller or equals to 1 is basically looking at those two. So smaller or equal to 1, it's 1 and 0. So if I add those two together, 0.2621 plus 0,3932, I get 0,9663. And so those two calculated is basically looking at the 0 and the 1. And to work out the mean, I've added again how we would work out the mean. So like I said earlier, they need to give us to us. So they tell us it is n is 6, pi is 0,2. So if I multiply those two together, I get 1.2, which is the option 5 that they have given us. Okay, what they do like in binomial is to nearly ask you a few probabilities, and then either the mean or the variance they will ask you to work out as one of the options. Not a lot of times that they will ask you both, because to add just the 1 minus pi extra, they will rather ask you another probability question. Okay, so binomial, when they ask you to calculate it, the easiest for me is always to look at the tables. But again, if you're more comfortable doing it another way, you can do it what your preference is. Okay, let's just quickly stop here, get a check-in. Okay, so let's continue looking at the next one. Okay, so again, what is important, I just want to check. So here they tell us a certain type of tomato seed germinates 90% of the time. So that is nearly your rate that they give us. A backyard farmer plant 25 seeds, so you have your N is equal to 25, and then the expected number of seeds that germinate is. Okay, so they're asking us to work out the expected number. The expected number is mean. So nothing more that in this one that we needed to do, I just say, okay, 25 times 0.9 will give me that answer, which is 22.5. Okay, which is option 5. So this looked quite daunting, but actually, if we just need to work out the mean, it is straightforward from a formula. Okay, if I ask us what is the expected mean of seeds that does not germinate, how would you have calculated that? So what would your pi have been for the does not? Okay, so nearly I will look at perfect. Great, yeah, 0.1. So, and Peter, it comes again down to what you asked way at the beginning. So if it germinates 0.9, but not germinate, if I add the two together, it needs to give me 1 again. Okay, so think about it also as in the heads and tails. So if a coin was not equal, and we said it will get us 0.9 times heads, then the other one, the 0.1, will be tails. So with binomial, always also your expected the it happening plus not happening will always be equal to 1. Okay, so again, sometimes and I have seen it in one paper before, where they actually ask the opposite. So they give you the 0.8 or the 0.9, but they want you to work with the 0.1. So just again, always be on the lookout for that. What I included here is just so that how the tables read. Um, so when we get the pi, anything up until, so let's just say small or equal to 0.5, we use this top part. So when we had the pi equal to 2 or 0.2, there it was. We remember we looked at n is equal to x. We would have gotten the values there, and it's very simple to read it off because we know where the 0.2 is, we know where the x is, we know where the n is. If in the instance here where they ask us 0.9, now I don't see it at the top, okay, but you will see in your textbook or in your study guide that you've got a one piece of paper, and then at the bottom actually it goes on. So then it starts where it starts at 0.01, goes to 0.5. At the bottom it's 0.5 and it goes to 0.99. So again, if you look at that, and you add the two together, you will get 1. If you look at the 0.98, 0.02, if you add the two together, you get 1. So if we needed to look at the 0.9, we would have gone, okay, 0.5, don't work there. Okay, here's 0.9. Then we would have said, okay, but on this table, how we need to read it. So instead of reading it from 0 downwards, we read it from 0 upwards. Okay, so that first number would have been x at 3 with pi equal to 0.9 would have been that number. That would have been 4, 5, 6, 7, 8, 9, 10. Okay, so again, just want to show how we can use the table in a different way. If you don't have the pi that it's equal to any of these, then use an online calculator. You won't in the exam get something like that. They might do it in the assignments because they nearly testing you. Exams, it will be straightforward. So it will be all from the top line, all from the bottom line. The numbers will be there. You won't need to, in the exam, need to get to a weird number that now suddenly is not in here. So if you look at, they will not ask you 0.71, because then you now need to guess between numbers, and that's not the value, any value in it. Okay, so just wanted to show you how to read the binomial if you need to look at anything where pi is bigger than 0.5, then you use the bottom part of it. Okay, yes, what's the question? Let's got another minute or two or a few minutes, so let's quickly check this last one. We can look at the others next week. So suppose that 10% of butterflies have damaged wings. If a random sample of 10 butterflies is selected, what is the probability that more than 4 have damaged wings? Okay, so I assume that should have been, so let's just see. 10, so we can work with that. Just want to make sure that we use the right one. Okay, so if that's 90, this one will be 0.1, so that will be the 10%. And x would be 0, 1, 2, 3, 4, 5, 6, 7. Okay, so suppose that 10% of butterflies have damaged wings. If a random sample of 10 butterflies are selected, what is the probability that more than 4 will have damaged wings? Okay, more than 4. So anything above 4. So it is 5, 6, or above. So more than 4 would be 5, 6, and 7. So if I add those three together, I get 0.0016. Okay, so now again, let's just read it again. What is the probability that more than 4? So more than 4 is not including 4 is 5, 6, 7, 8, 9, or 10. In this instance, those probabilities of 8, 9, and 10 is so small, they don't even give it to us. So we only then need to add the probability of 5, 6, and 7. So if, again, we needed to write it down, it would have been what is the probability of x bigger than 4. It could have been also what is the probability of x bigger or equal to 5. Okay, because then it includes 5 and bigger. So this is two ways that we could have written it as well as a formula. Okay, so another way to look at it, and again by using the 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 nearly the tables, if we were using the formulas now, we would have done it 1, 2, 3. Which does bring in complexity and then mistakes that can happen with your calculation of it as well. Okay, let's stop here for the evening. Questions on this thus far. So discrete, we've covered most of binomial. Next week we will look at Poisson, and then we'll just start doing a recap before your second assignment is due as well. Any questions tonight? Okay. If there's nothing, I'll make the video also available a bit later tonight, and yeah, I'll also share some of the other documents that I have on the WhatsApp group. So again, if you're not part of the WhatsApp group yet, please send me a WhatsApp on that number 0837908387. I'll just add you to the group so that you can get some of the other um, things to help assist as well. So summaries and those kind of things. Okay, everyone, have a good evening. And if you're still writing, good luck with the exams. But I think most are starting to end now. But good luck, everyone.
Thanks,
Yes,
Tom.